In section 3.3, we're going to be working on dividing polynomials. Now, our warm-up today, which you should have already completed before starting this video, was about elementary school long division just with regular numbers. The steps when we were doing that was to divide, then multiply, subtract, bring down, and repeat. We're going to keep those same ideas when we apply these concepts to polynomials. So this is what a problem might look like. If we are dividing the dividend, x cubed plus 4x squared minus 5x plus 5, divided by x minus 3, this is our divisor. What we're going to do first is we're going to divide the first term by the first term. So x cubed divided by x is x squared. Be sure to line up the x squareds above each other. The next step, and don't draw this on your notes because you're going to be annoyed with how messy it is we're going to multiply the x squared to both pieces of the divisor, in which case we would get x cubed minus 3x squared. Now, this next step is to divide, and when I'm actively doing this problem, I'm going to show a little bit different work than what is shown on your screen, but you are actually subtracting, I think I said divide earlier, subtracting both of those terms before you bring down the next term in our polynomial. Repeating, divide, multiply, subtract, bring down, repeat, until we get a remainder. Now, in the elementary school long division, I asked you to write it in the form q of x plus r of x over d of x, which is your quotient, plus your remainder over your divisor. So if we're doing that again, we have our quotient, x squared plus 7x plus 16, plus our remainder, 53, over our divisor, which in this case is the polynomial x minus 3. That's how we would write our final answers for this long division of polynomials. Let's keep going right on in. So we're going to divide x squared plus 10x plus 21. That's our dividend, x squared plus 10x plus 21. And we're going to divide that by x plus 3. If we start this right away, again, we are going to divide the first term by the first term. X squared divided by x is regular x. I be sure to line up the x's on top of each other. Then I'm going to multiply x times x, which is x squared, and x times 3, which is positive 3x. Again, what I'm doing is x times x and x times 3. Like a little distribution question. Now, here's where my steps will look different than what was printed on the paper. I'm going to have you subtract everything. You are going to have to stay with me on this because we're going to distribute this negative inside essentially. X squared minus x squared can and should cancel out. But then I have 10x minus 3x. Make sure you actually subtract that to get 7x. And then you bring down the 21. Repeat. First term divided by first term. So 7x divided by x is just regular 7. Then we multiply 7 times x is 7x, and 7 times 3 is 21. We're going to subtract, so 7x minus 7x cancels, 21 minus 21 also cancels, we have a remainder of 0. So our answer, our quotient would be x plus 7 plus 0 over x plus 3, but since it's 0, we don't need to use it. Now, a good question you might have is, well, how many times do we repeat until we're done? So let's add a little note right here. We're going to keep repeating until the degree of the remainder is less than the degree of the divisor. So again, my divisor was degree 1. My remainder, now that it's just a regular number, is a constant degree 0. So we're good. This is going to come in handy when we get to the examples on the bottom here. We have 2 more examples to try. We'll zoom in on the first one. Divide 4 minus 5x minus x squared plus 6x cubed by 3x minus 2. Now, interesting, when we go to write this one down, we need to make sure we take this divisor and we write it in actually standard form. So I'm going to start with the largest exponent, 6x cubed, and then my minus x squared, and then my minus 5x, and my positive 4. We want to be sure it's written in standard form, so then we can write 3x minus 2 as our dividend. First term divided by first term. 6 divided by 3 is 2. X cubed divided by x is x squared. So I'm going to put 2x squareds above the x squared term. Then we distribute, we multiply. 2x squared times 3x is 6x cubed. 2x squared times negative 2 is negative 4x squared. Now remember, we are subtracting all of this. The first terms can and should cancel, but we are subtracting negative 4x squared. Minus a negative is plus, so that's negative 1x squared plus 4x squared. I get positive 3x squareds. We bring down the 5x. First term, divide by first term. 3x squared divided by 3x is a positive 1x. Then we distribute. 3x times x is 3x squared. Negative 2 times x is negative 2x. We subtract everything. The first terms can and should cancel, but after that we have negative negative, which is positive, so it's negative 5x plus 2x, which is negative 3x. Bring down the plus 4. Now again, because later on this is going to be important, we're checking usually that our remainder, what we have gotten after we finish the step before we repeat, is smaller degree than our divisor. These are equal degree. They're both degree 1, so we keep going. We would do negative 3x divided by negative 3. Well, that's negative 1. Negative 1 times 3x is negative 3x. Negative 1 times negative 2 is positive 2. But we're subtracting all of this. Minus a minus cancels out. Minus a minus becomes positive. So negative 3x plus 3x cancels out. And then we have 4 minus 2, which is 2. Since there's nothing else to bring down, and because this remainder is a smaller degree than my divisor, this has no x's at all, we are done and we can write our answer, our quotient. Our quotient would be 2x squared plus x minus 1 plus the remainder 2 over the divisor 3x minus 2. So we have our quotient that comes from the top of the long division box, our remainder, and our divisor. Let's check out this one. Okay, so now we have 6x to the fourth plus 5x cubed plus 3x minus 5, and we're dividing it by 3x squared minus 2x. When you go to write this down, it is mostly in standard form, but we have 6x to the fourth power, and then third power, and then it would skip down to the first power. Where's the second power? Interesting. So if you are missing a particular power, you have to put a placeholder 0 in that spot. We need to see every single term in the standard form. Otherwise, we are missing a term, and we put a 0. Now we can go and do our division. So 3x squared minus 2x. And if you're thinking to yourself, Miss Quigley, it says degree 2, then degree 1, and then there's no constant term in that divisor. It's okay if the missing term is at the end, but if it's missing in the middle, that's where the problem is. Now we start our steps. We would divide 6x to the fourth power divided by 3x to the second. 6 divided by 3 is 2. X to the fourth divided by x squared is x squared. Now I make sure I line that up over the x squareds. See how I skipped 2 this time? We're keeping the x's aligned. We distribute 2x squared times 3x squared. That's 6x to the fourth. 2 times negative 2 is negative 4x to the third. We are subtracting all of that. First term can and should cancel. Minus a minus is plus. That makes this 9x cubed. We bring down the 0x squared that we had to add in. Divide. 9 divided by 3 is 3. X cubed divided by x squared is x. Multiply. 3x times 3x squared is 9x cubed. 3x times negative 2x is negative 6x squared. First terms can and should cancel when you subtract. Minus a minus is plus. This is 6x squared. Quick check. The degree here is 2. The degree here is 2. We should still keep going. 6x squared divided by 3x squared is 2. We multiply 6x squared and negative 4x. Subtract. First term can and should cancel. This is minus a minus, so we add. This is 7x. Then we bring down. Now here's the thing. Our remainder is degree 1. Our divisor is degree 2. The remainder is smaller than the divisor in degree, so we stop. That is actually our remainder. Our remainder is a binomial. Our quotient answer would be 2x squared plus 3x plus 2 plus 7x minus 5 over 3x squared minus 2x. Remainder over divisor. At this point, I want you guys to pause the video and go try questions 1 and 2 on your classwork. Classwork is on the back of your warm-up questions. There is, however, a second form of dividing polynomials that we can use, and that's called synthetic division. Now, synthetic division is great except for the fact that it can only be used when your divisor is of the form x minus c. Put a whole bunch of exclamation points next to this. So there's very few actual division problems where you can use synthetic division. This is going to be used more when we're maybe factoring a polynomial. Synthetic division is performed by setting up only the coefficients of the dividend, like if you had x cubed plus 4x squared minus 5x plus 5, so 1, 4, negative 5, 5. And then the divisor, so the solution here, the opposite of what you see, x minus 3 would just be a 3 right here. And you start by bringing down that first coefficient, bring down. Then you multiply on the diagonal. 1 times 3 is 3. Add straight down. 3 times 7 is 21. Add straight down. 3 times 16 is 48. Add straight down. The last number you get is your remainder, then your constant, then your x squared, if there was more x cubed, and on and on. So again, the steps are bring down, multiply, add, multiply, add, multiply, add, till you can't do it anymore. Now the same rules apply in synthetic division, that if you are missing any terms in your dividend, that you have to put a 0 there. So if we're using synthetic division here to divide 5x cubed plus 6x plus 8, I recognize that if I have 5x squareds, x cubed, we have no x squareds, 6 x's, and 8 constants. We're going to divide all of that by x plus 2, which means I put negative 2 on the outside. This is the setup. 5, missing term, 6, 8. And since we're dividing it by x plus 2, I use minus 2 on the outside. The steps are bring down, multiply on the diagonal. So negative 2 times 5, I'm going to write it underneath the 0. That's negative 10. Add straight down. Multiply, that's positive 20. Add straight down. Multiply, that's negative 52. Add straight down. So that we have the remainder, the constant, the x, and the x squared term. So to write our final quotient, we would say that this is 5x squared minus 10x plus 26 plus negative 44 over x plus 2. Now, there may be another way that this is written, and since plus a negative is kind of like double signs, there is a more simplified way to write this as just subtracting that remainder. To show that you understand synthetic division, stop the video right here and before going on to the theorems, and I want you to try example 3 on your classwork. It's going to ask you to use both long division and synthetic division to divide a quotient. Now, one of the reasons we use synthetic division is for factoring, which is the main idea of this chapter, is to be able to find the x-intercepts or the roots, the zeros, the solutions. We have a couple theorems that go along with that. The remainder theorem says that if the polynomial is divided by a factor x minus c, then the remainder is f of c. So we can also use the backwards of this, that if you wanted to find f of c, the evaluated at a particular term, all you'd have to do is divide x minus c and get the remainder. Meaning, if we're given f of x equal to x cubed minus 4x squared plus 5x plus 3, and we wanted to find f of 2, all we would do is synthetically divide these two things. We're going to do 2 on the outside, 1, negative 4, 5, and 3 as the coefficients of the dividend. Bring down, multiply, add, multiply, add, multiply, add. I tell you that f of 2 is equal to 5. Whatever number we get in that remainder spot. Now, this is not a hard one to actually evaluate. F of 2 is literally just telling me to take 2 and plug that into the function. So here I go doing that. 2 to the third power is 8. 2 squared is 4. 4 times 4 is 16. 5 times 2 is 10 plus 3. 8 minus 16 is negative 8. 10 plus 3 is 13. Negative 8 plus 13 is 5. Oh, snap, that looks familiar. We got the same thing by simply synthetically dividing. Nice. So if you're wanting to evaluate a function, you can divide by it and get the remainder. When we start to look at the factor theorem, this is the main reason we study division of polynomials, is so that eventually we can factor and solve polynomials for their real zeros. Now, we have a whole bunch of words here that talk about the factor theorem, but the main thing I need you to know is that if you're dividing a polynomial and if the remainder is 0, that means that whatever you divided by, x minus c, divides evenly into that polynomial, which is what we would call factors the polynomial. Which means we're going to be very easily able to use synthetic division and division to find all of the zeros of a polynomial. This adds another tool to our toolkit. Example 6 says solve the equation 2x cubed minus 3x squared minus 11x plus 6 equal to 0, given that 3 is a 0 of the function. Well, if we know that 3 is a 0, we know that it will divide evenly, or that x minus 3 will divide evenly. That's what we know. So that we don't have to use grouping, so that we don't have to use some of the formulas we used last class to solve a quadratic or a polynomial, what we can do instead is divide this polynomial by x minus 3 using synthetic division. So we have 2, negative 3, negative 11, and 6 as the coefficients for my dividend. I'm dividing it by x minus 3, so I put a 3 right there. Bring down, multiply, add, multiply, add, multiply, add. This is good. We needed the remainder to be 0 because that means it divides evenly, or it actually factors that polynomial. That was our remainder. This is our c, this is x squared. So at this point, we have factored this polynomial down to x minus 3 times 2x squared plus 3x minus 2. If you did not know how to factor before today, this next step is going to be hard, and you might want to use the factor theorem again, which we will go over next class. But what we would do after this is, since it's now a quadratic, that means that we can factor and solve. We're looking for two terms that we're going to multiply to 2 and eventually add to 3 when we FOIL it. The numbers that multiply to 2 are 1 times 2, and so we check this first. This would be 4. This would be 1. I can make 3 if this is a -1 and a +4. Once I'm in fully factored form, which again, you guys did this at the whiteboard at the beginning of class last time, factoring this, we used the 0 we were given, the quotient, and factored. Now it's in fully factored form, we can find the zeros at 3, at 1/2, and at -2 to solve this polynomial. This ability to use the factor theorem to quickly factor a polynomial down at least a degree or maybe 2 is vital for us to be able to, next class, solve some more complicated polynomials. At this point in class, I want you to, well, the video is almost over. I want you to stop the video and try question 4 and 5 on your classwork. When you finish this classwork, it should be turned in. Do not take it home with you. I need it turned in before you leave, with the elementary long division review done, which you should have done before this video, and then the 5 questions on the back. You can work with the people near you if you have not done so already, as if this was the questions on the whiteboards, which they would have been if I had been there today. See y'all next time.